Okay, guys, welcome back to my YouTube channel. If you are here to subscribe to this channel, please can you do so? Like my videos, comment, and also share with your friends so that they can learn from these videos. The topic we are looking at today is matrices. Um, we're going to be looking at understanding what a matrix is, understanding the notation, and the order of a matrix. We shall also be talking about addition and multiplication of matrices. There are four knowledge that, things you should have known before now in this class, basically your algebra and all the rest, vector notation, including position vectors, by the time we begin to apply this to this topic. Okay, so let's get right to it. What is a matrix? That's where we're going to start from. What is a matrix? Now, here's an example of a matrix right here. You see the brackets, you see the numbers that are written inside in a particular order. That means that it's arranged in a particular pattern, okay? When we have numbers arranged in this kind of pattern, inside a bracket of this nature, that is a matrix, okay? So a matrix can contain any type of numbers. You can see in that example up there, 3, 2, minus 5. Those are positive numbers, whole numbers, negative whole numbers. You could have a decimal, you could have a fraction, you could even have, a sort as an element or a number inside a matrix. So the numbers are enclosed in brackets, okay? That helps us to define what a matrix is. Enclosed in a bracket, numbers arranged in a specific pattern. Now, like I said, the numbers always make a rectangular pattern, okay? So that specific pattern is a rectangular pattern. Now, look at this example right here. This is not a matrix. This is not a matrix because it doesn't form a rectangular pattern. Now, that rectangular pattern, it could be a square, actually. So we can actually have a square pattern, okay, but not triangle. This is not an example of a matrix, okay? Then given this example, you can see that the pattern in which the numbers are actually arranged in this bracket, you can see rows and you can see columns. Now, what are we trying to say here? Basically, you can observe that these numbers in particular, okay, which is from 3 to 5, 3 to 5, that is arranged in a particular row. And I have 2.13 over 4 and root 2 arranged in another particular row. So we can simply say that this is row 1, and we can say that this is row 2. So this matrix has 2 rows. All right, so let's take note of that. So arrangement of numbers horizontally shows the rows of the matrix, okay? While vertical arrangement shows columns. So we have 2 rows and we have 3 columns inside this matrix. Okay, let's take a look at that as well for this. So if we have, this is going to be column 1, and this is column 2, and this is column 3. Okay, so there are 3 columns right here, which we have to take note of. So this is, let me just write out. This is column 1, and then I'll just call it C2, column 2, and C3, column 3. So 3 columns, 2 rows. Okay, so let's take note of that. So you can see matrices basically in terms of these rows and columns in order to describe the kind of matrix that we are talking about. This particular example describes this matrix as a 2 by 3 matrix. So we pronounce that as 2 by 3. Okay, please let's take note that the 2 that you have, we know that already, is the number of rows by the number of columns. So we can define the order of a matrix by the number of rows by the number of columns. Now, this example right here is a 3 by 1 matrix. And why is that so? It is a 3 by 1 matrix simply because you can observe very quickly that there are 3 rows. This is row 1, row 2, and row 3. There are 3 rows, and then you have a single column, just one column. So 3 rows, I'm going to use, call that R1, row 1, row 2, and row 3. But there's a single column, so column 1. So this is a 3 by 1 matrix. A 3 by 1 matrix. So every time you want to write the order of a matrix, you write it by writing the number of rows by the number of columns. Okay, so let's take note of that. The first number is the number of rows, while the second number is the number of columns. I think that is really very clear. So we move on that and take a quick look at what we have next. So this is another example right here, if I quickly take this away to show us that this matrix right here is an example of a 1 by 4 matrix. You can observe here that there are 4 columns, but a single row. 4 columns, but a single row. There's just 1 row in this case. So I can easily identify that apart from that, I also have 1, okay, take that back. I have 2, I have 3, and I have 4 columns, okay? So in that case, we're looking at a situation whereby you're talking about only 1 row, but C1, C2, C3, C4, 4 columns. So this is going to be a 1 by 4 matrix. That's the order of this matrix, a 1 by 4 matrix. So let's take note of that. So moving on with that, talking about, that was just discussing about the order of matrix. We also like to quickly note that you can also have a 1 by 1 matrix. This is an example of a 1 by 1 matrix. You just have it right there to talk about 5. Because in this case of this 5, you can identify that there is only 1 element. So obviously, you can only account for 1 row, and you can only account for 1 column in this case. So 1 row, 1 column is a 1 by 1 matrix. So let's take note of that. Okay, we don't really use that much, but it is a possible matrix with 1 row and 1 column. So I think that is really very clear and very, very understandable. So let's move on and see what we have next. A matrix may be used to store information. That is to let us know that if you would like to store information, we can use matrix to store it. For example, you see here that we have a Cartesian plane, the XY plane, where you have 3 points A, B, C, D, 3 points A, B, C with their coordinates. So each of these coordinates, we are able to represent it with a matrix, okay? So 2, 1 is for point A. The first row talks about the X values for the first row, while the second row talks about the Y values in a Cartesian plane. So you can see that for point B, you have 5, 2. So this is 5 and 2. And for point C, you have 3, 5. So that's an example of an application of matrices, which is used to store information. Moving on. Now, the plural of matrix is matrices. So when you have more than 1 matrix, you call it matrices. Suppose that we have 2 matrices here, matrix A and matrix B. These are the elements inside it. I want to believe that all of you can quickly tell me the order of these 2 matrices, okay? Based on explanation previously, you'll be able to count the number of rows by the number of columns. And based on that, you will agree with me that this is a 2 by 2 matrix because there are 2 rows and also 2 columns. This is also another 2 by 2 matrix, 2 rows and 2 columns. Definitely, you can see that from the matrix, row 1, row 2, then column 1, then column 2. So these are 2 by 2 matrices, and based on that, we're going to add these matrices together. This is quickly going to be showing us how to add matrices together. Now, we add the matrices by adding the number of corresponding numbers in the corresponding positions. Now, that simply means that for you to have the solution to the addition of these two matrices, A plus B, you need to add the elements inside matrix A to the elements inside matrix B. But the pattern of doing that is you have to add elements or numbers in corresponding positions. Corresponding positions in the sense that elements in the same position, but in the different matrices, definitely. So you see that element 3 here, or this number 3, and this number 6 are located in the same position. So those are the two numbers you must add, so that 3 plus 9 will give you, 3 plus 6 rather, will give you 9. And then moving on from there, you now pick on the next position, 5 right here, plus 1 in the same position with 5 gives us 6. And the result, take note guys, is also written in that same position in the addition matrix. Okay, next you have to add 4 in this position to minus 1 in that position, in the same position. So 4 plus minus 1 is actually 4 minus 1, which will give us 3, and the result is written in that same position. And lastly, you add 2 plus 0, elements in the same position added together, and then you have 2 there. So that is the pattern of how to add matrices together. Now, can any pair of matrices be added? Now, when we talk about any pair of matrices, what we're talking about is, can you add any type of orders together? Maybe 2 by 2 added to 2 by 3, or 2 by 2 added to 1 by 2, or 2 by 3 added to 5 by 2. Is that possible? Can we just add any pair of matrices together? The answer is no. Okay, and the reason why it is no is because we can only add matrices that have the same order. Okay, and this also extends to subtraction, addition and subtraction. When you want to subtract matrices or add matrices, you need to take note that their orders must be the same before you can add. For example, this addition that we did here, you were able to realize that the first one is a 2 by 2, and the second one is also a 2 by 2. They have the same order. That is why we're able to add them together. And when you add two matrices or you subtract, the result must also be of the same order as well, also 2 by 2. So let us all take note of that. So based on that, that will help us to push further in this topic, trying to make more reference to what we're talking about, that you can't add all types of matrices together. It's only those that have the same order that you can add or subtract. So we can't add these ones, for example. Now, this is a 2 by 1 matrix. You cannot add it to a 1 by 2 matrix because they are of different orders. That addition cannot take place. So let's take note of that. This is not possible. Okay, this is not possible. All right, so let's move on and take a look at the next thing here. But we can actually add these ones together because they are of the same order. So you're going to expect that the addition here, when you add these two matrices together, should also give a 2 by 1 matrix. So elements in the same position, 3 plus 2, should actually give us 5. And elements in the same position as well, which is 4 plus 6, should give us 10. And that should be our result right there. So I think that is very much clear to us. And you realize that the answer that you even get right here is also of the same order with the two matrices. So 5, 10 here is also 2 by 1. Very interesting topic, as you can see. So let's take the next one. We have when we say multiplying by a scalar. So now we are talking about multiplication now. We have discussed the order of a matrix. We have discussed addition of matrices, which is also the same explanation that goes for subtraction. Now, let us talk about multiplying matrices. Now, the first type of multiplication we're going to talk about is when you want to multiply a matrix by a scalar. And by a scalar, this just means multiplying by a number, not another matrix, okay? Multiplying by a number. You want to multiply a matrix by a number. So let's try to give an illustration. And we do this by multiplying every number in the matrix by this scalar or by this number. For example, you can see this matrix here, the matrix with elements 3, 8, minus 2, 0. We want to multiply that matrix by the scalar 2. That means by the number 2. What will happen is just that 2 will multiply each of the numbers, all the numbers, one after the other, in that matrix. So 2 times 3 is going to give you 6, and then 2 times 8 is going to give you 16, and then 2 times minus 2 will give minus 4, and then 2 times 0 will give 0. So that is how to multiply a matrix by a scalar or a number. I think that is pretty clear. Now, the scalar may be a negative number. In fact, it can be any number. Okay, so that's why we call it a scalar. If it's a negative number, for example, if you multiply minus 3 by this matrix 4 and minus 6, you definitely have the first to be minus 12, which is minus 3 times 4, that's minus 12. And then minus 3 times minus 6 will give you positive 18. Of course, we can also multiply by a decimal number. Okay, it's any number. That's why we call it scalar. If you multiply that, 0.1 is going to multiply each of the elements in this matrix. It will multiply 3, it will multiply 6, it will multiply minus 2. So 0.1 times 3 will give 0.3, 0.1 times 0.6 will give, 0.1 times 6 rather, will give 0.6, and 0.1 times minus 2 will give minus 0.2. Also, that scalar can also be a fraction. The matrix I have here, I want to multiply by the fraction half. So half of 12 is going to give us 6. Half of minus 8 is going to give us minus 4. Half of 3 is going to give us 1.5. And it can also be a surd. I can multiply a surd by a matrix. So if this root 2 is going to multiply each of the numbers inside this matrix, I'm going to have the first one to be root 2 times 3, which is 3 root 2. The second one to be root 2 times root 2, which is 2. And then root 2 times 4 root 2 is going to be 4 times 2, which is 8. And then root 2 times 1 over root 2 will simply give 1. So that confirms all of that. Now, that shows how to multiply a matrix by a number or a scalar in general. Now, there is an algebra of matrices. For example, if matrix A and matrix B are given to us, then if I have something like 2A plus B, that means 2 times matrix A plus 3 times the matrix B. What does that mean? What it means is that you have to work out 2A, that means multiplying matrix A by 2. You also have to work out multiplying matrix B by 3, and then add the answers together. So this only works when A and B have the same order, don't forget, because addition of matrices, subtraction of matrices, they only work when you have the same order, okay? All right, let's have this as example. Matrix A and matrix B with the same order. I'm sure you can understand that the order of these matrices that we have here is 3 by what? 3 by 1. Thank you. Because you have 3 rows and 1 column. So these matrices are 3 by 1 matrices. Okay, moving on. To now solve or simplify 2A plus 3B, you're going to have to multiply matrix A by 2. That's the first thing to do. So you do 2 times 4 to get 8, 2 times 1 to get 2, 2 times 2 to get 4. And for 3B, you do 3 times 5 to get 15, 3 times 2 to get 6, and 3 times minus 3 to get minus 9. And finally, you can then do the addition. Remember, addition of matrices, you add elements in the same position together. So 8 plus 15 gives 23, 2 plus 6 gives 8, and then 4 plus minus 9 gives minus 5. And that is how that goes for that. Now, let's try to write the order of each matrix as examples and class activity. So let's take a look at this. This is a matrix here. To know the order of this matrix, what do I need to know? I need to check how many rows and how many columns. So here I have 2 rows, row 1 and row 2. So 2 rows here. Okay, so let me just put that in as 2. And then, of course, I have only one, okay? I have only one column. The next one, I can see here that I have 2 rows. Pardon me, I have 1, 2, 3. 3 rows for this one. I go again, 1, 2, and 3. There are 3 rows. So that makes me to have 3 right here. How many columns? I have 1 and 2. So this has to be 2 right here. Okay, so moving on for that. Over here, I can see here that I have 1 row and 2. So 2 rows. And then the columns 1, 2, 3, 4. I have 4 columns. So this is a 2 by 4 matrix. This is a 2 by 4 matrix. 2 by 4 matrix. Okay, let's come to the next side here. We want to write this addition as a single matrix. So we want to perform the addition here. Remember, addition is to be done by adding elements in the same position together. So 7 here plus 7, and that should give 14. 0 here plus 9, I believe that should give 9. Okay. Also, I should have 6 plus minus 6, that should definitely give us 0. Minus 1 plus minus 5, that should definitely give us minus 6. Okay, and then 4 plus 4, that should give us 8. And lastly, 7 plus 7 again should give 14. Now let's take a look at the next one. This is to write 5A plus 3B as a single matrix. Of course, remember you have to multiply the matrix A by 5 first, and also the matrix B by 3 before you then add them together. So let's try to see what we have for that. If I multiply, let's do the 5A. The 5A is going to be equal to 5 multiplied by each of the elements. So 5 times 9, I'm going to have 45. And then 5 times 9 again, another 45. 5 times minus 1, I'm going to have minus 5. And then 5 times 8, I'm going to have 40. So this is 5A. Now let's do 3B. 3B is going to be equal to 3 times minus 4. Your focus is on matrix B now, guys. 3 times minus 4, I have minus 12. 3 times 3, I have 9. 3 times 6, I have 18. 3 times minus 3, I have minus 9. So finally, I can then add them together. So that is going to give me 45 plus minus 12, okay? And that is going to give us 33. So I'm going to have to come in here to put the result here as 33. And then 45 plus 9, that's the next one. 45, which is 45 here, plus the 9 here, elements in the same position. 45 plus 9 is going to give us 54. So we come here and then we drop 54 here. That's going to give 13. Minus 5 plus 18 will give 13. And we now do 40 plus minus 9, which is 40 minus 9, to give 31. And there we go. We have all our answers correct. So that is how this goes. You've learned how to identify the orders of a matrix. You've learned how to write the addition of two matrices. You can add them, and then you can also multiply by scalar and also add doing the algebra of matrices. Guys, please take note. This addition is the same process for subtraction. You're going to see that in a couple of minutes soon. All right, so let's move to the next aspect of this topic. So now we want to look at a situation whereby just something that will look practical enough to real life situation. Two teachers order some pens, and the first teacher orders 8 packs of blue pens and 3 packs of red pens. That's for the first teacher. So we have 8 and 3, 8 for blue and 3 for red. We have a second teacher that ordered 10 packs of blue pens and 2 packs of red pens. So 10 and 2 for the second teacher. Now this matrix holds the information for complete order. Okay, so each pack of blue pens contains 20 pens. Okay, so and then each pack of red pens contains 10 pens. So which shows that we can actually put this here as 20 and 10. That is the complete pack. Okay, you know they were buying packs. Okay, they ordered for packs. So that means that the teacher that ordered 8 packs of blue pens, and a pack contains how many? 20. So definitely you know what we're talking about. So let's see how that goes. Now, how many pens did each teacher order altogether? So you see what I mean now? We're going to expect 8 here to be multiplied by 20, okay, because there are 20 packs, 20 pens in a pack. Of course, the 3 red pens will multiply by 10 because there are the 3 packs of red pen will be multiplied by 10 because there are 10 pens in a pack for red pens. So the first teacher ordered 8 times 20 and also ordered 3 times 10. So 8 packs of blue pen, 3 packs of red pens. So since there are 20 in a pack, it will be 8 times 20, and there are 10 in a pack for the red, it will be 3 times 10. Now please follow that pattern of multiplication because that is how you understand how to multiply 2 matrices together. Now, I will do you a better explanation to show you guys that what we're saying is that this particular element multiplies the first element right here, while the second element multiplies the next element right here. You know, so you can see it as row times column. Okay, first row times the first column. We only have one column here anyway. That's another way to take a look at it. Okay, I'll explain more about that. So if I'm to multiply this for the second teacher now, okay, well, you can see that 8 times 20, 160, and then 3 times 10 is 30. The addition of that gives us 190. So we have 190 here. So now, let's take a look for what happens for the second teacher, the number of pens he or she ordered altogether. I'm sure you're already following my explanation. So let's take a quick peek into that and see how we multiply that. Of course, you'll agree with me that now we are focusing on the second row. So it means that this 10 is going to multiply 20. And then we're going to have 2, the red pen, to multiply the 10. The same procedure, okay? Likewise here before, it was also this 3 that multiplied 10. And then it was this 8 over here that multiplied 20. So you can follow the pattern, but please be careful. Please be careful. I'm going to remove something now. When you are doing this, it is important that you realize that the pattern or the process is that you're expected to multiply, okay, this first row multiplies this column. But the pattern of that multiplication is that the first element, blue, multiplies the first in this column as well, blue, and the second element, red, multiplies the second red as well in that column. The same thing happens for the second row. So once I'm done with first row, first column, based on this multiplication, I will also go ahead to have the second row multiplying that same column as well to give us the next result. You see that black answer here, and then when I do that multiplication, 10 times 20 is going to give us plus 2 times 10. So 10 times 20 is 200, 2 times 10 is 20. That should give us 220 in addition. Now look at the order of the matrix, guys. We multiplied a 2 by 2 by a 2 by 1, okay? And we got the result of a 2 by 1. Now what does that tell us? That if we multiply an A by B matrix by a B by C matrix, our result should be A by C matrix. So A very easy way to actually quickly understand that is once you write the order of the two matrices side by side like this, A by B is multiplying B by C, or B by C, yes. You will observe something very important here. And what is that? Please take note of what I'm showing you guys right here. Now, what you observe is that the second number here, which is the number of columns for the first matrix, and the first number here, which is the number of rows of my second matrix, they are the same. That is a condition for two matrices to be multiplied. If you don't have this condition, you cannot multiply those two matrices. Now for the result. The result is definitely going to be the first number here and the second number here. So that when you multiply, you get A by C order for the result of your matrices. So please, of your matrix rather. So please take note of that very important concept, okay? For me to know that I can multiply two matrices, the number of columns of the first matrix, okay, must be equal to the number of rows of the second matrix. I repeat, for me to know that I can multiply two matrices, the number of columns of the first matrix must be equal to the number of rows of the second matrix. Once that is discovered, then it is possible to multiply. We call that a name that is common to us, okay? And that name is simply to say that the two matrices are multiplicable. So you can multiply them together. But if these two are not the same, you cannot multiply those two matrices. So when they are the same, and you want to know the order of the result, it will just be the first and the second of the second matrix. That will be the order of your result. So that is very interesting. We now have another teacher who wants to order 14 blue packs and 3 red packs. Let's see what happens with that. Including one more teacher, we show the new matrix multiplication because we need an extra row, okay, in the first matrix for a new teacher to come in. So this is a new teacher right here with 14 blue packs and 3 red packs. Of course, when you do the multiplication, 14 will go ahead to multiply 20, and the 14 will go ahead again. Now 3 again will go ahead to multiply 10. So we'll do 14 times 20. I think you're getting the pattern now. 14 times 20, that's for the third row. So first element in the column. Okay, let me put the indication. So this has to go this way. This row multiplies the column. So the first element, and then it goes right ahead. The next one will be plus 3 times 10. Second element in that row times the second element in the column you are multiplying with. So 3 times 10, and when you add it together, you end up having 310 as the final answer there. So you can see what has happened now. What happened here is that the order of the matrix that I have now is 3 by 2 multiplied by 2 by 1 now. What is the result? 3 by 1. 3 by 1. And the multiplication was possible because the number of columns of the first matrix is the same as the number of rows of the second matrix. So that's a very good concept and understanding you have to keep. Questions can be asked on it at any point in time. So we're showing you that again. These two numbers must be the same for the multiplication to be possible. As well, these two numbers also tells us the order of the answer of our multiplication. Okay, guys, suppose now that another supplier puts blue pens in packs of 10 and red pens in packs of 5. So we're trying to say that instead of one column now, we're going to be having 2 columns, okay? In the sense that you have 1 column, 2 columns here. So How do we perform this multiplication now? Let's take a look at it. Of course, you know, it's an extra additional column has been added to the second matrix here. So let's see what will happen when we multiply. Now, this first column in my results here, that one has been done already. That is when you did, let me show you guys that so that you understand what is going on. Let me use blue to underline this. This row times this column, okay, gave us this 190. Let me use another color now. This row times this column again gave us 220. I'll take another one. This row times this column, the same column, that's how it works, gives us the 310 that we have here. Now that we have a new column, you have to go through it again the way you did the first column here. Okay, so that means I'm going to have to multiply this row again, this first row, okay, this first row here. I'm going to have to multiply by the second column now with the same pattern of multiplication. What do I mean? I mean 8 times 10 and 3 times 5. That's the pattern of the multiplication. So let's go right to it, guys, and multiply. So when we do that, we're going to have 8 times 10 plus 3 times 5. That gives 95 over here. So which simply means that I have done my multiplication for the first row times that column. Okay, follow my colors of the lines to see how I'm working with it. The next one will be my pink, which is the second row. That second row here is going to multiply, the second row here is going to multiply this column now. So it's going to be 10 times 10 plus 2 times 5. 10 times 10 plus 2 times 5. That's how we go about that now. So we check a look at that, you see that we have 110 for that. So we've been able to do that for the second row. Now finally for the third row now. For the third row now, okay, which is right here, to multiply with the second column, we're going to have 14 times 10 plus 3 times 5. So we have that to give us 115. So that shows that I have been able to multiply with my third row, okay? So see the pattern now. First row, first column, second row, first column, third row, first column. Then you go again for the second column. First row, second column, second row, second column, third row, third column. So follow the pattern, guys. So the way we have the result, you would have seen that this goes, the answer here goes along with the orange color there. And then the second one here goes with the pink. And then the last one goes with, the first one there goes with the blue. So once you follow that, in fact, quickly you understand how it was done. These are the results over here for the matrix. And that is how multiplying two matrices is done. Please go over it again and understand the concept. So that is that. Okay, again, looking at the order of the matrices, guys. Looking at the order of the matrices again, 3 by 2 multiplies 2 by 2. The result is 3 by 2. And you can see now that the two numbers here, here and here, they both have the same number. That is why the multiplication was possible. Remember, those numbers must be the same for multiplication to occur. Okay, and the numbers that you have taken out here now, 3 here and also 2 here, are what makes up the order of our answer. Now, what does the final matrix tell us? The first column tells us the number of pens each teacher ordered using the first supplier. And then the second column, which is right here, tells us the number that was ordered using the second supplier. So finally, let us work out these matrix multiplications based on the explanation that was given previously. To multiply this, put your answers in those boxes, okay? All right, and then multiply this, put your answers there. Multiply this with this as well, put your answer here. Multiply this with this as well, put your answers here. So guys, this will be the classwork for today. I will expect that you put your answers in a particular pattern for me, and this is how I want you to put it. It's going to be going on Padlet, okay? That's where you put your submissions for me, all right? You can simply write your answers out for me this way, okay, so that I have your result coming absolutely. When you want to write it, just write it this way. I'm going to have your answers like this. So it goes from, maybe this is the first one. I can have this to be the first one, the second one, the third one, and the fourth one in that arrangement. First, second, third, fourth, okay? So that means when you're writing your answers, just write, my answer is maybe 7, 13, 6, 2. Write it that way, okay? In that position, first, second, third, and fourth. Let me repeat it again. First, second, third, and fourth. The way I've written it in this place, that's how you arrange it, okay? Let me put it up again. This will be for your first number, this will be for your second number, this will be for your third, and this will be for the fourth. So write your answer out for me like that, in that order. Please take note, in that order. This is the first, second, third, fourth. I repeat it again. This first number, that's the first, put a comma. This will be your second, put a comma. This will be your third, put a comma. And this will be your fourth. And that is that. Of course, you know for this one, the same arrangement goes again. Let's make this the first one, the second, the third, the fourth, the fifth, the sixth, the seventh, and the eighth. Over here too, of course, this definitely, I see just one box here, is expected to give only one number. So here, we can take this as first, take this as the second, this is the third, this is fourth, and this is the fifth, and this is the sixth. So I expect the arrangement of those numbers to come in that order, guys. Take note of this. This is the first here. Don't arrange it in any other way. This one has only one number, so I can just say first. Nothing much for that. So an example of an answer here could be written this way. When you write your answer for me in the Padlet, just write maybe 7, 6, 15, 21, 13, 12, 5, 1, 2, 3, 4, 5, 6, 7. One more, then 10. So this is how I'll see your answer on my Padlet. This represents the first, second, okay? Understand the pattern though. First, second, third, fourth, fifth, sixth, seventh, and eighth. That's how you arrange it, based on the way it should be in these boxes. And I think you understand how that pattern goes now. An answer for the last one here will be seen as maybe 16, minus 5, minus 7, 4, 2, minus 1. 1, 2, 3, 4, 5, 6. So you write your answer like that for me. So guys, let's take note basically for that. And what you are taking note of is the fact that when you are numbering it, when you are sending your answers to me, this is numbered number 1, okay? This is numbered number 2, this is numbered number 3, and this is numbered number 4. So sending your answers to my Padlet, right on Edmodo, I am going to be pasting the Padlet link where you will supply your answers for this classwork. Thank you very much, guys, for being in class today. I'm going to see you in my next video very, very soon. Remember to like, comment, and hit the subscribe button and also the notification so that you get to anytime I post new videos. Thank you, guys, and bye for now.